Alright, for number 2 here, we've got a word problem. We have an airplane is currently flying at a height of 15,000 feet and is going to be flying in for a landing. If the runway that the plane is landing on is 80,000 feet away, what is the angle of depression from the nose of the plane to the start of this runway? So here, whenever we're going through and solving this, first of all, you can think of this in terms of parallel lines. We've got this part that I have marked here is our angle of depression. That would be our theta. That would be our angle of depression here. But in this case, since this runs parallel to the ground, we're assuming that the plane is horizontal at this point and it's running parallel to the ground. So then that would mean that this angle down here would be equal to the same amount. That would also be our angle theta. That would be equal to the same amount because that would be using that alternate interior angles property that we had from before whenever we were dealing with our parallel lines and a transversal line. So if we have that as our theta and that's equal to that angle of depression that we're solving for, we can go through and use our tangent function here because in this case the 15,000 is our opposite side and our adjacent side would be down here as that 80,000 because the hypotenuse would be this angle, that angled part there. That would be your hypotenuse, which we don't have to solve for in this case. We need to figure out what that angle measurement is. So here in this case, we can set this up as the tangent of theta is equal to that opposite side, which was that 15,000, over the adjacent side, which was 80,000. So we can simplify that down. We'd have tangent of theta is equal to, and then in this case, the decimal is not repeating, it does terminate. So you could go ahead and either write it as a decimal for your scratch work there, or you could simplify the fraction. So if we were to simplify this fraction, it'd be 3 over 16. Or if you write it as a decimal, that would be 0.1875. Make sure to remember if it is a repeating decimal, it keeps going and going. You want to make sure to write it as the fraction for sure instead to keep it exact. In this case, you could do it either way since it is a terminating decimal. And then kind of like we did before, if you're trying to solve for that angle, you can use the inverse of that trig function, in this case the inverse of tangent, and then you'd plug in what the value it was equal to. So in this case the 0.1875, and then that'll be equal to your theta value. So kind of like multiplication and division. Multiplication and division are opposites. Your tangent and your inverse tangent are opposites. They cancel each other out. So here, if you do the inverse tangent of that 0.1875, then for your theta value here, you should get approximately 10.62. And remember, we're always dealing with degrees here. So make sure if you are getting a different answer that you double check to make sure that your mode is in terms of degrees and not radians. And if you do have questions, make sure to ask.